Hi, I'm Brett. I'm with Random Guys. We're a virtual band. We do 70s and 80s covers virtually. Some pretty good music. Check us out on Facebook, Random Guys Virtual Band. I play saxophone for the band, but I also do the audio and the video engineering. And I put together a series of videos on audio topics. So if you're doing audio, maybe you're doing house of worship, maybe you're doing live sound reinforcement, maybe you're doing studio recording, or you might just be at home doing your own mixing. If you're doing audio, you might find these videos helpful. So let's check out today's video. So let's talk a little bit about impedance. What is impedance? Well, as the word suggests, it's resistance. It's impeding something. And we can talk about the impedance of a source of energy, electrical energy. We can talk about the impedance of a destination or the load, the electrical load. Or we can talk about the impedance of the signal between the two of them. As a source, if I have low impedance, it means I have a lot of power to give. That's another way to look at impedance. Low means more power. If I'm a source, I have power to give. A battery is a low impedance source. The electrical wall outlet is a low impedance source. Lots of power behind it. As a load, it means I need a lot of power to drive me. So this speaker right here is an 8 ohm speaker. It's fairly low impedance. It needs a lot of power to drive the speaker, make any noise out of this. This SM57, this is an SM57 microphone. It has a 330 ohm impedance nominally. Now what's the difference between impedance and resistance? Resistance is a constant, never changes. No matter how much frequency you run through a resistor, it's always the same resistance. Impedance is frequency dependent. So it's like resistance, it's measured in ohms just like resistance, but it is frequency dependent. So higher frequencies may have a higher ohm value than lower frequencies depending on the particular source or load. This is 330 ohms nominal. It changes over some various frequencies. I've got this hooked up right now through this XLR cable jack right here. And this jack is hooked up to an oscilloscope. This oscilloscope is set at 50 millivolts per division. So let's move this down right in the center. And I'm going to do my best to simulate a sine wave. And we're looking at about 2 divisions at 50 millivolts, about 100 millivolts. That's not much. 1/1000th of a volt, so 100 thousandths of a volt. 0.10 volts, or 0.1 volt actually, coming out of this. 1/10 of a volt. 100 millivolts. All right, so I'm coming into a very high impedance load here. This oscilloscope impedance is in the order of megohms, millions of ohms, so very, very high impedance. Why would I want mega ohms as impedance for oscilloscope? Well, I want to be able to look at any signal, no matter its impedance, and not load that signal down. So one rule of thumb is if you're sourcing something and you want all of it to get to your destination, you want to source from a source that's lower impedance than your destination, than your load. And so if this is 330 ohms going into a 1 megohm or even higher impedance, most of the energy, if not pretty much most of it, is going to get to this oscilloscope so I can see everything that this thing can give. Let's see what happens when we plug an SM57 directly into an 8 ohm speaker. So this is the output right here, 1/8 inch jack from converting XLR to 1/8 inch unbalanced. The XLR is balanced, but I'm taking just the unbalanced signal, and we're going to go right into this speaker. Just plug the speaker right here, right into that. There. Now this microphone is powering this speaker basically. So what happens when I try to speak in this microphone? First of all, aim the speaker so you can hear if anything comes out. Ooh, what happened to my signal? Did it just kill the SM57? There's nothing, almost nothing. Look at that. Still the same 50 millivolt scale. Nothing's changed, but I'm not getting a signal. That's because I've overloaded this. I'm trying to drive an 8 ohm speaker with a 330 ohm source. Can't be done. As you can see. Now, did I kill the SM57 doing that? Did I hurt it? Let's see. Nope. No, still works. Didn't hurt it. It's almost nothing you can do to hurt S57. But you can see what happens when you take a medium impedance source, 330 ohm, and try to drive a low impedance load. Can't be done. You don't have enough power in this signal to drive the power needed for this load. All right, so let's see what happens when we take now the SM57, instead of plugging it directly to a speaker, we plug it into a preamplifier. So here's an unbalanced preamplifier I built with some components on hand. This is the output, unbalanced output from the XLR cable, so directly from the XLR, we plug it right into the preamp. That preamp's a little noisy. But you can see we haven't loaded the signal very much, so the preamp has about the same impedance as this signal here. I'm getting about 50 millivolts off this microphone now, so it is actually being loaded a little bit by this preamp. So open circuit with no load on it at all, I was getting about 100 millivolts out of it. So as soon as I place it across a load, now I'm seeing about 50 millivolts, which is still the range of, I think the operational range of this is expected to be about 40 millivolts. So here's another preamplifier. Let's put it in another preamplifier. So same setup, different preamp. So this is a kit preamp. This one I put together out of components I had. This is a kit preamp that I ordered off of Amazon. And it comes as a kit, you solder it together. But it's a preamp that inputs and amplifies low-level signals such as coming off a microphone. So again, without loading, got about 100 millivolts coming off the microphone. I plug it into here, different preamp. Ooh, that's loading it more. It must be a lower impedance than the one I built. Let's go down to 20 millivolts and see what we get. Looking around 20 millivolts now that I can get off this microphone when it's loaded with this input impedance off this preamplifier. So you can see what impedance does. It loads down the signal. And so you want to go from a lower impedance source to a higher impedance destination or load. That's one of the rules. Now another rule is a high impedance. Let's take a look at the oscilloscope here. And let's just unhook it. It's not hooked to anything. Not hooked to the microphone, not hooked to anything. This is a very high impedance source over megohm. It looks like we've got some activity going on there. Let's see what we got going on. And so look at that. That's 60 cycle hum. It's picking it up out of the air. It's picking it up off of some source around here that's radiating 60 cycle. It's acting as an antenna and picking up out of the air. It's receiving it. So one of the things about a high impedance, very high impedance, and you probably won't encounter that anywhere in audio, but one thing to know about very high impedance signals is they are very susceptible to have noise induced on them. So this is sitting there all by itself. You can see I pick it up, I'm starting to introduce noise, I'm collecting noise. You see I touch it, even more noise, just coming off my body. So a very high impedance, the higher the impedance, the more susceptible it is to picking up noise. So there's some things to know about impedance, but mainly the rule of thumb for audio is you want to make sure you go from a device that has a lower impedance than the destination you're trying to drive. And that's why you go through at least two stages of amplification. Those stages are also matching impedance. So this microphone is driving a preamp. Out of the preamp comes a signal that's lower impedance, driving the input of a power amp. And out of the power amp, it's capable of driving very low impedance, down to 2 ohms usually. But it can certainly drive an 8 ohm speaker. So hopefully that helps you understand impedance a little bit better.